So here we go. We're going to look at these notes on multiplying and dividing real numbers. Now, what happens if you multiply some number times 0? It's 0. Doesn't matter what the number is. If I multiply that number times 0, I'm going to get 0, right? So don't forget that. That is one reason why if I'm solving an equation, I can multiply both sides by the same number, and that's a perfectly legal thing to do, but I can't use 0, okay? Now, let's talk about those sign rules. We reviewed the addition and subtraction rules earlier in class today, and we said if I'm adding numbers and I look at the signs and the signs are the same, what do I do to get the number part of the answer? I add. Whatever their absolute values are, I add. So I add up the numbers, and then what's going to be the sign? If my signs are the same, after I add the numbers, I keep the same sign. Very good. If I'm adding and the signs are different, what do I do with the numbers? There you go. Subtract the absolute values, and my answer takes the sign of the larger number, the number that has the larger absolute value. We said we can change any subtraction problem to addition as long as we do what? Add the opposite. It means I have to make how many marks on my paper if I want to change a subtraction sign? 2. I got to make 2 marks on my paper if I'm changing that subtraction sign. Now let's talk about multiplying. And the rules for multiplying are so much easier, multiplying or dividing, because all I'm going to do is check to see if the signs are the same or if I have an even number of negative signs, because sometimes I might be multiplying more than 2 numbers, and if I am, I can still figure out what the sign of the answer is if all I do is count up how many negative signs I see. And if it's an even number of negative signs, my answer will be what sign? Positive. Very good. So that's going to be the sign if I have an even number of negative signs. Now, if the signs are different, if I only had 2 numbers I was multiplying or dividing, or if I have an odd number of negative signs, what's going to be the sign of the answer? Negative. That's all I have to remember about the sign rules if I'm multiplying or dividing. Okay, so let's fill in the box here. We just wrote it out there, but let's reinforce it. Product of 2 numbers having the same sign. By the way, product means you do what with the numbers? Multiply. So if I'm multiplying, the signs are the same, I get a positive. Very good. If I'm dividing, because that's what quotient means, and the sign is the same, I get what sign? Positive. Doesn't matter if I'm multiplying or dividing. As long as it's a negative divided by a negative, I still get a positive. Now, if I'm multiplying and the 2 numbers have different signs, then the sign of the answer is negative. And if I'm dividing and the signs are different, or the answer will be negative. Okay, so those rules are pretty easy to remember. Just be careful that you don't get mixed up between the rules for addition and the rules for multiplying. Now, reminders of division rules. We've already done leave, change, flip when we're working with fractions. So we know about reciprocals. That's what happens when I flip it. And one thing you might have forgotten, if I take a number and I multiply it times its reciprocal, what will that equal? 1 every single time. Every single time, because it's going to give you the same number on top and bottom if you multiply straight across. Now, this is the one that you got to be careful about. People tend to forget this. What happens if I divide by 0? I am so proud of you. It is undefined. It can't happen. Now, let me show you why real quickly, because sometimes if all you're trying to do is memorize a rule, it doesn't make sense. But if you understand why the rule is there, it makes it easier to remember. So think about it this way. It's written out here, but I think it's kind of hard to the form of division on this problem makes it a little harder to see. So let me just kind of point this out. When you learned how to divide back in elementary school, if your teacher gave you 6 divided by 2, you were told that after you got the answer, which is what? 3, how would you check your work? Remember? There you go. This answer times the denominator should equal the numerator, right? 3 times 2 equals 6. And that's because we say that division and multiplication are inverse properties. That simply means one undoes the other. So if I multiply something together, I can undo it by dividing by the same number. Or if I divide, I can undo it if I multiply by the same number. But look at this. If I took 6 and I divide it by 0, and I ask you what that equals, this is asking me what number do you multiply times 0, and the answer would be 6. Can I multiply any number times 0 and get something different from 0? That's why it is undefined, or you might say the empty set. That looks like a 0 with a slash through it. Make sure you don't ever write that when you mean the number 0. That means empty set or undefined. Okay? But that's why division by 0 isn't possible, because if I divide by 0, there's no number I could multiply by 0 to get what's in the numerator. Okay? Now, our sign rules are going to come into play here. We already said if I'm dividing and I have one negative divided by a positive, a negative divided by a positive, I know my answer needs to be negative, right? If I'm working with fractions, you've got 3 places you can put the negative sign, and any of them are perfectly acceptable. You can attach it to the numerator, you can attach it to the denominator, or you can just put it out in front of the whole fraction. Any of those, as long as there's only one negative sign, you're good. So let's real quickly make sure we've got our sign rules down. Look at number 1. Negative 5 times negative 6 is what? What sign? Positive. And 5 times 6 is 30. Good job. All right. What about negative 8 divided by 2? First of all, tell me about the sign. Negative, because I see one negative sign there, and then 8 divided by 2 is 4. So negative 4 would be the answer on that. Now, let's make sure we can keep up with this one. It's a fraction, but now we've got the sign rule to keep up with too. So what am I supposed to do when it's fraction divided by a fraction? Keep, change, flip. So I'm going to keep the 1/4. What am I going to change the division to? Multiplying, and then I'm going to, flip negative 2/3 and make it 3 over, and it doesn't matter if I put the negative sign down here with the 2 or I put the negative sign on top. I just need one negative sign somewhere, okay? And now, if I multiply, what do I end up with? Negative 3/8. I didn't have anything that would reduce down, so I just multiply straight across, and that would be my answer, negative 3/8. Now give me a quick signal. Are we here, here, or here on the sign rules with multiplying and dividing? Okay, most everybody, these are easier than the adding and subtracting, right? Okay. Don't worry so much about the decimals. This would be something you could put in your calculator, but make sure you know what's a negative divided by a negative. It's going to be a positive. So then it's just a matter of whatever number the calculator gives you. Now look at this one. You've got 3 things being multiplied together on number 4. Negative 4 times 3 times negative 6. Tell me about the sign of the answer. How do you know? There's 2 negative signs. So that means it's going to be a positive, and then I would just multiply out the 4 times 3, which is 12, and 12 times 6 is 72. You could do that in your calculator. What about this one, number 6, -3 divided by 0? Excellent, undefined. Oops. And then we've got a couple of order of operations questions. I want you to see if you can come up with the right answer on number 7. So you figure out what you need to do first, and then we'll talk to see if we all get the same thing. Okay, so I'm sure you're not finished yet. You already are, very good. Can you tell me, where do you think we should start?
The -1, -5.
Excellent. I've got braces here, or I'm sorry, brackets here, and inside the brackets, I see there are 2 things that need to be multiplied, and I've got a subtraction. So I want to multiply first inside the bracket. So I've got -8 bracket, -1 minus. Now, when you multiply -4 times -5, what'd you get?
-20.
Is positive 20, but there is a subtraction sign in front of where I get 20. So I can see why you might be tempted to say -20, but it's actually a -1 minus 20 inside that bracket. Now, what would you need to do next? We did the multiplying. Say it again.
Or subtract -1.
Because I want to finish up what's inside the bracket, right? And I've got -1 minus 20. Now, I don't know about you guys, but I kind of have to be careful. That sort of freaks out my brain a little bit, looking like that. Can I change it to adding the opposite? If I do, that becomes -1 plus -20. Now, is that hard to add? I hope you say no. What is -1 plus -20? So if I take -8 and I multiply it times -21, what's the sign of my answer? Positive. And what's 8 times 21? 168. Okay. So how many of you say, I'm feeling pretty good about order of operations and sign rules now? How many of you say, still working on it? Okay, got the idea? Do we need to, you want to do number 8, or do you think you got it? Maybe we should do number 8. So remember, on the fractions, do I worry about the fact that it's a fraction when I start it? No, instead I'm just going to focus on what? Focus on the numerator, figure out what number that's going to be, then you go take care of the denominator. And after you do that, then you can see how it cleans up. So take a second to start on that. We'll see what you get. All right, so what did you decide needs to happen first?
So
We do have parentheses on bottom, and we could take care of that. But I'm thinking, let's just go ahead and clean up on the numerator. And then you're right, when we get to the denominator, we will do what's inside the parentheses first. So when I look at the numerator, what would be the first thing I need to do there? Multiply, because I've got 6 times -4, then I see a subtraction sign, and then I've got 2 times 3. So I want to do all the multiplying first. So how much was 6 times -4? And then I see a subtraction sign. How much was 2 times 3? 6. Okay. And then in the denominator, you said the 2 minus 7. Now, I'm kind of not sure about 2 minus 7, so could I rewrite that as what? If I change it to adding the opposite, it becomes what? 2 plus negative 7. Now, how much is 2 plus a negative 7? Negative 5. Very good. Because the signs are different. Subtract the numbers, and then my answer will take the sign of the larger number. So we got to finish the cleanup on the top. Negative 24, and again, I see this subtraction. So if I change it to adding the opposite, it means I've got negative 24 plus negative 6, which is a negative 30, over, now what's going to be on the denominator? Negative 15. And what's a negative divided by a negative? And the number is 2. How many of you got 2? I'm curious. A few of you. Okay. So with a little more practice and taking your time, as long as you're using order of operations, you should be good, correct? Okay, correct. Now, most of you have gotten to the part in the homework where you've had to do some evaluating of expressions, and it meant you were putting in a number to replace a variable. So let me just kind of walk you through this, and here's where we're going to start to see some exponents that we'll have to be careful with. Here is the way I like to, well, let's put it this way. The biggest mistake students typically make on these kind of problems is you put down a negative sign that if you then are supposed to replace a variable with a negative number, you kind of think, oh, I've already got the negative, and you will mess up on signs because you saw a minus sign already there and you didn't write another one. So to avoid that mistake, when we're going to be doing a replacement, I always put an open parentheses where the variable was, and then I'll come back and put the number in its place that that variable is supposed to be. So instead of putting 2x minus 7 and in parentheses y plus 1, I've got 2 open parentheses minus 7, and inside my parentheses, I put parentheses plus 1. Now, what number belongs in this first parentheses? Negative 4. What number belongs in the second parentheses? 3. By putting the parentheses there, it does a couple of things for me. It first of all makes sure I understand that the number that went in for x was a negative 4. Also, if I didn't put a parentheses there and I just wrote after the 2 a minus 4, I might think I'm supposed to subtract. I wouldn't understand that I'm supposed to multiply. Because if I have a 2 with an x right next to it, that's 2 times x. So I've got to make sure I remember that's supposed to be multiplication. Now it's just order of operations. So where do we start with this guy? Yeah, and in the parentheses it says 3 plus 1. So how much is 3 plus 1? So here's what I've got now. 2 times negative 4 minus 7 times 4. What would you do next? I've got some multiplying I can do. What's the first multiplication I see? 2 times negative 4, which is negative 8. And then I see a subtraction sign, and then I do 7 times 4, which is 28. Okay, now do you guys know what a negative 8 minus 28 is going to equal? We're not getting the same number. Good. Remember, as long as you think of this as adding the opposite, it makes it a lot easier to see, wait a minute, they're the same sign. I just add the numbers and keep the sign, and that's how you get a negative 36. Okay? Now, let's practice this one with some exponents. So I'm going to do the same thing. I'm going to put a 3, open parentheses, put my exponent, minus 4, open parentheses, and my exponent. And then what goes in the first parentheses? A negative 2. What goes in the second parentheses? A negative 3. Now, especially if you're using a calculator, these parentheses are required. Because I just told you earlier that if you don't have a parentheses around it and you just type -2 and then hit x squared, it's not going to give you the right answer for this because it's going to do order of operations according to what you tell it. Without the parentheses, it's only going to square the 2, and then it's going to put the negative sign in front of it. With the parentheses, it means -2 times -2. So what should happen first in cleaning this guy up? The exponents. Because inside the parentheses, I just have a number. Can't do anything, but I do have exponents. So what's getting squared here? The -2. And what is -2 when you square it? So that means I can replace this with 4 minus 4, and now let's do the same thing here. What is that going to clean up to be? -3 in parentheses squared is, and it's positive, isn't it? Does that make sense? I hope so. If you need help with that in a little bit, you tell me and we'll spend some more time working on it. All right, go from here. I want to see if you guys can get the right answer from this point forward. Okay, so if you've been working on this, I've got a question. Did you come up with a positive number or a negative number? Gosh, we're not unanimous. I hear some positives and some negatives. Is it a single digit number or a double digit number? Double digit number. On count of 3, tell me what you think it is. 1, 2, 3. I think the majority of you have it right. There may be a few of you got a little bit confused. If you multiplied next, this was a 12 minus 4 times 9 is 36. If you think of it as adding the opposite, because the signs are different, I know I subtract, that's where the 24 comes from, but what sign should it be? Negative, because the 36 is bigger than 12, and since 36 was negative, my answer will be negative. How many of you got it right? Okay, that's the majority of you. Good job. Now, do you remember something called the distributive property? There you go. And the thing about the distributive property, I mean, think about this for a minute. If I came in here and maybe I had little pieces of paper, coupons, that said, you get a bonus 5 points on your first test. And I said, this is your lucky day. I'm going to distribute these to the class. And I start passing them out. And I go around the rows, but I don't give one to Kelsey. I give one to everybody, but I don't give one to Kelsey. Is she going to have a problem with that? Yeah. I think she would, and she should, because if you're going to distribute, you've got to make sure you distribute to everyone. So just like you said, Keith, if there's a number in front of a parentheses, and the parentheses has more than one term, that means there's plus signs or minus signs inside, I've got to make sure it gets distributed to every term. Otherwise, I'm breaking a rule here. So this is explaining if we have something in front of the parentheses, it gets multiplied times term 1 and term 2, and it will equal that. It doesn't matter if the number is actually after the parentheses. Sometimes it's written that way. You still distribute it to everything that's inside, okay? Also, keep in mind, if you see that the number you're wanting to distribute is a negative number, you can think of that as -1 times that number, depending on how you're distributing. You may find that that's helpful to think of it like that, may not be. So let's look at this and see if we can distribute correctly. If we multiply everything in here by 2, what will we get?
2p.
2p. Excellent. That's pretty easy. Now, is it a problem if the number that's in front is a negative number? What would we get on number 2?
-4y plus -3a.
Okay.
Be negative 4y minus, like you
Oh,
gotta
yeah.
multiply the negative 4 into it first.
Very good. We got to multiply the negative 4 times the y, which is where that comes from. But remember, it's also got to multiply times the 3x. Now, it's okay with me if you put a plus sign and then you say negative 4 times 3x is negative 12x. If you wanted to just write it as negative 4y minus 12x, that's okay too. Because remember, subtraction is the same thing as plus a negative, adding the opposite. So however it helps you to keep up with signs, feel free to do that. Or because you could also think of it as a negative 4 times a positive 3x. And if you think of it that way, that's why you might write it like this. Here's another thing that I think is helpful. Anytime we're distributing, remember that the sign that's in front of a number stays with the number. Kind of like what happens in Vegas stays in Vegas. So if this was a negative 4, that negative is going to stay with the 4 as I distribute. Since that's a plus sign, it means I'm going to think of that as a positive 3x. And when I multiply negative times a positive, that's how I get a negative. Now, look at this. I don't see a number in front of the parentheses, but what do I see? A negative sign. If I just see a negative sign, that's really the same thing as what? A negative 1. So it's like I'm multiplying everything in this parentheses by a negative 1. I think I heard Kelsey say it's also the same idea as taking the opposite sign of everything in there. And that's another way you can think about it if there's just a negative sign in front. But if we want to distribute using negative 1, this is going to equal what? Negative 3k plus 5. Oops. Plus 5, because a negative times a negative gives me a positive, right? That does not want to, right, there we go. Okay, so negative 3k plus 5. Okay, fractions, don't worry too much about the distributing of fractions right now. We'll talk about them when we get to a place that we need them. I would like for you to try to do number 6 on your own, and let's see what you guys come up with. I'm going to point one other thing out while you guys are writing. However many terms you have in the parentheses, you should still have that many terms after you distribute, okay? So if we looked at number 1, I have 1, 2, 3 terms in the parentheses, and I've got 1, 2, 3 terms after I distributed. Number 2, there's only 2 terms in the parentheses. I've got 2 terms after I distributed. So on number 6, after you distribute, you should have how many terms? 3. And what would they be? Negative 10x. Plus what? Good. 5 times 5 is 25. Y. And then what? Minus 30z. Oops. So give me a quick signal. How many of you say, I'm pretty good with distributing? This part doesn't scare me. Or I think I need a little more practice. Okay, we got the idea. Can we keep up with the signs now? Because we've covered the sign rules. Okay. Simplifying expressions. If you are looking for terms, and I just talked to you about terms are separated by what? Remember? Plus signs or minus signs. Things that are multiplied together, like this, negative 9 times x squared, or 15 times y, or 8 times m squared times n, those are just one term. If they're multiplied or divided, those factors or those quotients, that's fine. It's still just one term. But when you see plus signs or minus signs separating them, that means we've got more than one term. Okay? So you want to keep that in mind. Separated by plus signs or minus signs. We give a name to the number part that is in the term. It would be the number that's being multiplied times the variable. We call that a numerical coefficient. So for example, In negative 9x squared, what would be your coefficient? Negative 9. It's the number that's being multiplied times the variable. What about this? If I just see an x and I don't see a number in front of it? Because it's understood to be 1, right? So if there's just a variable there, no number in front of it, got to remember the coefficient is really 1. Also, if I have something that's written as a fraction, remember, because there's really a 1 in front of that variable, I could pull out the 1/3 as my coefficient and then multiply it times the variable x, as long as the x was in the top part of the fraction, okay? So let's see if we can find the coefficient in each of these terms. What would be the coefficient on A? 15. What's the coefficient on B? -2. How about on C? -18. What about on D? -1. And E is?
5/4.
Good. Remember, this is the same thing as 5/4 times x. So the 5/4 is the coefficient. Okay. Now, the reason we need to recognize terms and we need to understand where the coefficients are, what they mean, and basically a coefficient is just telling us how many times we're adding up that same variable. Like, for instance, if I see 3x, that means it's x plus x plus x. That's just a shortcut way. Multiplying is a shortcut way of adding things up, right? So it's telling me that I have 3 of those that were being added together. So if I need to put together like terms, we already know if we're adding fractions, we have to have like denominators. Working with just numbers, we've got that figured out. Now that there's variables involved, we've got to make sure we understand what makes like terms with variables. So here's the rule. You have to have exactly the same variable raised to exactly the same exponent for them to be like. So in other words, would x and y be like terms? No, because x just stands for a number. I don't know what it is, but it's some particular number. Y stands for a different number. Those aren't the same. So I can't put them together and act like I have 2 of something. I just have an x and I have a y. What about an x and an x squared? Are those going to be like? No, because the exponent on there means it's not the same number anymore. I took that number and I had to multiply it times itself. So in order to have like terms, it's got to have exactly the same variable raised to exactly the same power. And so if I look at these, would these be like or unlike? Well, it should be unlike instead of dislike. So these are like. What about on B? Yeah, these are unlike. I'm just going to put un. How about C? Are those going to be like terms? Unlike. Why would you say that?
The exponents are different.
Excellent. They both have x's and y's, but one of them has x to the 4th and the other one has x squared. And then they did the same thing. They mixed and matched the exponents. So those are not the same. How about D? Those are like, because it have x squared and y to the 4th. Okay, in both of those. How about on E? Let's vote. How many of you say unlike? How many of you say like? These are actually like. Here's why. Does it matter the order I multiply numbers in? In other words, is 2 times 3 the same thing as 3 times 2? It is. So K times T is the same thing as T times K. They don't have to be written in the same order. I just have to have the same variables raised to the same power. And that makes these like. Okay, so far so good? Oh goodness. Let's spread this guy back out. Okay. Now, if we're going to simplify, we want to remove any parentheses that you can by using the distributive property and combining like terms. So now this is why we need to recognize like terms, because if we have them, we want to combine them and simplify. So would you agree that 4K and 7K are like, or are they unlike? They're like. That means I can combine them. And all I have to do, it's like saying I have 4 of these Ks. It doesn't, it means a number. I don't know what it is. But just to make things easy, I can call it an apple if I want. So if K is an apple, I have 4 apples plus 7 apples. What would I have? 11 of those apples. All I do is add the coefficients, and that gives me 11K. That's it. Can I do 4R minus R? Are those like terms?
Yes.
So if I have 4 of those R's and I take away an R, how many do I have? 3R. Excellent. What about 8P plus 8P squared? Are those like? Those are unlike. So can I do anything with it? I'm done. That's as simple as it gets. Bless you. Okay, now notice we have multiple terms here. Some of them have X's, some of them have Y's, some of them don't even have a variable. So we're going to pick out, do we have more than one term with an X in it? Yes, I see 5X and a 2X. What do I get if I put those together? 7X. Now, what else do you notice we're going to be able to combine?
3Y.
Yeah, now, remember what I said earlier? The sign in front of a number, what? Stays with the number. So when I circle this up, I'm going to make sure I don't lose the negative sign that's in front of there. And I've got a negative 3Y and a negative 5Y. What do I get when I combine those? That's a negative 8Y, isn't it? Okay, and I can either write it as plus a negative 8Y, or I can just write minus 8Y. Totally up to you. So I've done my X's, I've done my Y's. Is there anything else on there that I haven't done yet? Minus 3. And it didn't have any other numbers that were constants. It means I don't have variables with them. So I just write down the minus 3. Okay. I would recommend making some symbols to either underline, circle, box, something on the like term, so you make sure you find everything and you don't leave anything off. What did we do on E? It says 3/4 X plus X. Am I going to square it? So what did we do up here on 4K plus 7K? We just add them up. Can I add 3/4 plus, what's the number in front of X?
1.
Ah, so what would 3/4 plus 1 be?
1 3/4.
So if I write 3/4 X plus 1X, and I think of 1 as 1 over 1, if I'm adding fractions, what do I have to get? Common denominator. What's going to be my common denominator? 4. How can I turn a 1 into a 4? Multiply by 4. And if I multiply the bottom by 4, I'm going to multiply the top by 4. Now when I add, I get what? Oh, be careful. I'm adding. 7 over 4 times X. Okay, so you may have to use some of those rules we learned about working with fractions. 16y squared minus 9y squared. Are those terms like or unlike? They're like, so what would I get if I combine them? 7y squared. Notice we do not change the exponent. The variable in the exponent stays exactly the same. We're only adding or subtracting the coefficients. Now we're going to mix in some distributive property along with combining terms. So I want us to go to H. Tell me what you think we should do on H.
-3K squared.
Okay, so if I'm thinking in terms of PEMDAS, I look inside this parentheses. Are these like terms? No. Are these like terms? So I can't clean up inside the parentheses. I don't have any exponents outside of parentheses. This variable has an exponent on it, but there's nothing I can do with that. So now it's time to look at multiplying, and I do have distributive property that needs to be done. Where's the first place I use distributive property? Good. It's like a -1 times everything in that first parenthesis. So tell me what to write down.
Negative 3k squared minus 5k.
Minus 5k. Very good. Then I have a plus sign and then 7 times all of this. Can I distribute there as well? Okay, so if I multiply 7 times k squared, that is,
7k
and then what's going to be my last term?
minus 28
Minus 28
k.
k. Whoa, hang on. Now, do you see some like terms?
Yep.
Okay, what do you notice we have?
Negative 3k squared and 7k squared.
So here's a negative 3k squared and a positive 7k squared. What's that going to give us? Good. Negative 3 plus 7 is positive 4k squared. Then I see a negative 5k and what else? A negative 28k. If I add those together, I get negative 33k. Okay, give me just a quick signal in general, what we've covered today. How you feeling? All right, I'm seeing a lot of thumbs up. That's a good thing. Do J on your own. I want to see if you can get J correct. And if you've got that, we're going to move on. All right. You guys got it? So when you finished cleaning this up, how many terms did you have in your final answer? It all cleaned up to be just one term? 2 terms, right? Okay, because one of them has a K in it, one of them doesn't, correct? All right, so let's see what you got on the first step. What did you decide needed to happen first? Distribute. What are you distributing?
3.
Did you distribute positive 3 or negative 3? If remember, the sign that's in front of a number stays with a number. If you want to, think of this as adding the opposite. It's really negative 3 that gets distributed through. So if we have 9k minus 6 plus, now if I distribute with the negative 3, what comes after this plus sign? Negative 6, and then what? Positive 15k. That got rid of all my parentheses, and it kept up with my signs. Okay, so if that minus sign is in front of what's in the parentheses, remember, it's getting distributed too. Now, if I were to put together like terms, what would I have? If I take care of the k's, this 9k gets added to what? And that equals how much? So that's 24k. That sounds pretty good. Okay. What else?
Negative 12.
Yeah, I have a negative 6 plus another negative 6, which is, if you said just one term, if you're not careful, you may think that those negative 6's canceled out, but they don't because they're the same sign. So I add them together and keep the same sign. All right, so if you're feeling okay with that, we're going to move on, and we're going to talk about with polynomials. Technically, we really don't have to. I don't think we need to worry about degree of a polynomial or degree of a term, but I do want to talk to you about what a polynomial is, because we will spend some time with that a little later in the semester. Poly, excuse me, is the root that means many. So many terms or many names, not the NOM part of nomial comes from name. So when we're talking about a polynomial, it typically is identifying that there is probably more than one term. Now, if there is just one term, we give it a special name, monomial. All right, so the M-O-N-O means one. If we're talking about two terms, it's called a what? Binomial, like a bicycle has two wheels, binomial, two terms. What do you think three terms is? Trinomial, just like you think of a tricycle. If you get up to four terms, we just start calling it a polynomial. We're not going to put special names on all of them, but binomials and trinomials and monomials we use very frequently. And so when we have all those terms, if we see that we have exponents on the variables, we try to write our polynomials in descending powers. What that means is we're going to put the one that has the biggest exponent first, and then we'll put the next smallest exponent and work our way down. Okay? So we've got some polynomials that we're going to try to simplify if possible. But if they don't simplify, we leave it like it is. We're going to identify the coefficient. And then I'm not going to ask you about the degree, but let's see if you can identify whether it's a monomial, a binomial, a trinomial, or just a polynomial. So what would be any like terms on A? No. So since there are no like terms, what's that thing going to be called? Good, because there were how many terms? 3 terms. Now, what would be the coefficients? 3, 2, and -4. Remember, the sign that's in front of a number is going to stay with the number. And that's the only part we're going to fill in. Now, can we simplify B? Do we have like terms?
Yeah.
Ooh, so what is this going to turn into? Well, if I, and so what does it turn into if I combine them? Well, as far as the name, let's go ahead and write what it is first, then you can tell me the name. So what is x cubed plus 4 more x cubes? 5 x cubes, right? Which the name would be monomial, because it's only one term. Good. So monomial. And what would be the coefficient? 5. Good job. Okay. Any terms that can be combined in C? Which ones? X to the 8th then. So how many x to the 8ths are there? 3, because remember, there's a 1 in front of this guy, even though I don't see it. So I had one of those, and I added 2 more. That gave me 3x to the 8 minus x to the 7. Okay, so now that I've combined what I can, how many terms are there? What does that mean it's called? A binomial. And what would be my coefficients? The first one is 3. The second one is, be careful, -1. Remember, the sign that's in front of a number stays with the number. So when there's a subtraction sign and x to the 7th, that's really the same thing as -1 times x to the 7th. Okay, so we have a little bit more of evaluating that we're going to look at. We're just going to do this first one. We're going to see what happens if x is -2. So again, my strong recommendation is you put an open parentheses anywhere there was an x, and then we're going to come back and fill in the number. So if we're going to use -2 for x, and I put -2 here, and I put -2 here, can you tell me what you need to do first? Well, inside the parentheses is just a number, so I can't really clean up there. But I do have an exponent, so what's getting raised to the 3rd power? The -2. Now, you tell me, what is -2 raised to the 3rd power? What does that mean? Well, hang on a minute. First of all, tell me what it means if my exponent's 3. tells me how many times -2 gets multiplied by itself. So that means -2 times -2 times -2. Okay, that's what -2 to the third means. So tell me about the sign I'm going to get,
Negative.
because there's 3 of those negatives. And then what's 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. So we've got 4 times -8 plus, now what is 8 times -2? And is it positive or negative? Because my signs are different. A positive times a negative gives me a negative. So -16, and then I have a -6. So let's finish this thing off. I still need to multiply 4 times -8. What's that? So I have a -32 plus a -16, and then it says -6, but I can write that as plus a -6, can't I? Add the opposite. So I'm adding 3 numbers that are negative. How do I do that? Add them all up, keep the sign. What are you going to get? Is it, I think it's -54. This is where you may want to double check yourself with the calculator, because 32 plus 16 would be 48, and 48 plus 6 is 54, and it's going to be negative. Okay? So far, so good? Now, if we have a bunch of polynomials, bunch of terms, I shouldn't say bunch of polynomials. If we have polynomials where there's a bunch of terms and we're supposed to be combining them, adding or subtracting, you've got a couple of ways you can go about it. You can do it horizontally, but if you do it horizontally, you really need to do what I was showing you a minute ago, where you underline, circle, box, something so you see that you have all the terms. It's kind of helpful if you want to rewrite them vertically and line them up. I mean, you guys can decide. It does mean you have to rewrite them, but if you're copying them down on your paper, if you copy them this way, it sort of makes it easier, because look at this. If it's in descending order, my x cubed comes first, my x squared second, my x last. If I'm adding these up, how many x cubes do I have? 10. What am I going to get when I add up the x squareds? -1 of those x squareds, right? Because a -3 plus a +2, signs are different, so I subtract, take the sign of the larger number, and then what's a +2x plus a -3x? Say it one more time. -1x, very good. And if you want to put the 1 in there, you can. You don't have to. But I think vertically is a little easier, but it's okay to do it horizontally if you want. Now, look at F, and we'll do it horizontally just so you can see. So my first polynomial is in the parentheses. I've got a plus sign, and then the second polynomial in the parentheses. So we got to identify if we've got some like terms. I see an x to the 4th in the first parentheses. Is there an x to the 4th in the second? So I'm going to underline both of those and add them up. What is 2x to the 4th plus a -3x to the 4th? Is it positive 1x or negative 1x? So it's a -1x to the 4th. I'm going to put the 1 in there. That's totally optional if it helps you write it down. Now, if I look at the next term, I see it's x squared. Do I also have an x squared in the other one? So I'm going to circle these. Don't forget, the sign in front of the number stays with the number. So what's a -6x squared plus 5x squared? Say it one more time. Good. So I can either write plus a -1x squared, or I can just write -x squared. Either one of those is fine. All right. What's the last thing we've got to identify? Yeah, the constants. So maybe I'll put a box. I got a, oops, sorry, that was a +7 here and a +2 here. What do I get if I put those together? +9. Does that make sense? Okay, so you can only combine what you have that would be like terms. Notice in here, this one has an x squared, this one doesn't. This one has an x cubed, and this one doesn't. So sometimes that happens. If I go to combine these, what would I get? What's the highest x? Okay, 6x cubed, I'm gonna write it down. It didn't have anything to combine with. Plus 3x squared. Now I do have x's in both of these places. So if I go back and I underline my x's, when those go together, it's what? Negative x. And then I have a plus 2 and a minus 7. When those go together, I get. All right, good job. You guys seem to be on top of this. That's awesome. All right, the trick with subtraction is do not forget that a minus sign in front of a parentheses means everything inside that parentheses is going to be subtracted. So the easiest thing to do with that means, to me, change your subtraction to adding the opposite. So if I see there's a subtraction sign and a parentheses with more than one term in it, I want to think of this as adding the opposite, which means I'm really multiplying everything inside there by -1.
Just like subtraction sign outside of parentheses. Change the sign.
You can do that as well. So if you were looking here, okay, we're going to do it both ways. If I change this to adding the opposite and I think about multiplying everything in here by -1, I really don't need parentheses on this first one. They were just there to show me that was actually the first polynomial. Now, if I multiply these terms by -1, what will I get next? -4y to the third plus 16y squared minus 2y. And then it's just like we were doing a minute ago, where you're going to group together like terms. This one down here, if we do what you were talking about, and you just are mentally realizing because of that subtraction sign, I got to change all these to the opposite. Instead of putting that plus a negative, you could do this, 6p to the 4th minus 8p to the 3rd plus 2p minus 1. And then what would you write next? Plus 7p to the 4th. Plus 12. And that's perfectly okay to just understand that subtraction means I've got to change all those signs to the opposite. And either way you want to do it is fine. You just do whatever will cause you to have the fewest sign mistakes, okay? If you think you get lost just trying to remember to write the opposite, then you might want to remember to multiply through by a -1. Once we've got it written that way, are we okay combining terms? You were doing really well with it a while ago. That's the only difference when it's subtraction. Let me scroll to this, and I think this may be the last. We're almost to the point that we will have covered everything that's in the review today. I'm excited. We get to start real stuff in college algebra next time. Let's remember how you multiply when you have polynomials. Now we're going to start by multiplying monomials. Remember, monomials are how many terms? Just one term. So if I have one term times one term. What's different is these terms probably have several factors. A number part, a coefficient, and then there may be variables which could or could not have exponents. Might have several different variables. So if I'm multiplying these monomials together, the easiest way to do it is just remember you're multiplying number times number, and then you're multiplying variable times variable. So in this example, -8 into the 6 times -9 into the 6. I multiply the -8 times the -9 to get a +72. And here's where you got to be careful. Is an m the same as an n? No. So they're just going to be m to the 6, n to the 6. All those still multiplied together. Okay. Make sure you recognize the difference between whether you're trying to add versus multiply. Okay. If there's a plus sign between them, don't multiply them together. That's telling you to add. And to add, you have to have like terms, okay? If I'm multiplying, then I'm going to multiply number times number, and then I'll take care of those variables. Let's just make sure we've got this straight. If I have 7q to the 5th plus 2q to the 5th, that's what? 9, oops, 9 what? 9q to the 5th. That's what we've been doing on the combining like terms. But if I wanted to multiply those two terms, what am I going to get? The 7 times 2 is 14. Now, keep in mind, we've got a little bit of reviewing on how you multiply with exponents. This q to the 5th actually means q multiplied together how many times? 5 times. And I'm going to multiply it times another q to the 5th. So I'm going to have 5 more of these. 1, 2, 3, 4, 5. Okay? That's how many q's. Do you remember what the shortcut rule is if you're multiplying and the bases are the same? What do you do with the exponents? You add them, because remember, this is just telling you how many times that number's getting, or that variable is getting multiplied times itself, times another one of those. That you just add up the exponent. It tells you how many times in all they got multiplied together. Okay, and I've got a sheet in there to review you on those exponent rules in case you have forgotten. Sometimes you're going to have distributive property where part of what gets distributed is going to be a variable with an exponent. So look at this. What if I had 5m to the 3rd and I wanted to distribute it through 2m plus 7? What would that equal? Okay, so I've got to multiply 5m to the 3rd times 2m. So you said the 5 times 2 gives us 10. And that's going to be m to the what power? He says 4. Do y'all agree? Let me pull this up a little bit so you can see it better. Okay, he says 4th power. Do y'all agree? Because I have 3 of these m's here and 1 more here. That's 4 in all getting multiplied together. Okay, why are you not wanting to mark? Oh, that is no bueno. Come on. There we go. Okay. Then we got to multiply this 5m to the 3rd times this plus 7 at the end. What is that going to give me? And so what do I need to write next? Plus 35m to the 3rd. Remember what we said about distributive property. However many terms were in the parentheses before you distributed, you should still have that many terms after you distribute. So 2 terms here, 2 terms here. All right, and then we could practice this one too. Do you think we need a little more practice with multiplying with a monomial? What would a negative 2x to the 4th times 3x squared give you? So the negative 2 times positive 3, he says it's negative 6. Are y'all good with that? Negative times a positive gives me a negative. Negative 6. And then the x to the 4th times x squared would be x to the 6th. Good job. Add those exponents. Now, what happens next? What do I get? So the negative 2 times the positive 2 is a negative 4. Okay, he says x to the 5th. This is right. Because there are 4 x's here and 1 more there. That's a total of 5 x's that get multiplied together. And then what's going to be the last term? Excellent. Negative times negative gives me a positive 10x to the 4th. Okay, quick signal. Are we good? Multiplying a monomial times a polynomial. All right. I know we're getting to the point that your brain's probably going, so this will be the last thing we cover, but I think this gets you to the point you should be able to finish those problems now in the review. Multiplying 2 polynomials. That is really using the distributive property more than once. And it depends on how many terms you have, how many times you're using the distributive property. Now, to me, if we try to distribute, we get it's easy to get lost if you write it this way. So I'm going to show you what I like to do to keep myself organized. I use a box, a rectangular box, to help me stay organized. So for example, if I had m plus 3 times m squared minus 2m plus 1, I could take everything in here and multiply it by m, and then I could take everything in here and multiply it by 3 and write it all down and look for my like terms. But the box to me is a lot easier. Here's how I make my box. I count up my terms here. There are 2 terms. My terms here are how many? 3. So what that means is I want to make a rectangle that's 2 rows by 3 columns. So here's 2 rows, 3 columns. And where I have my 2 rows, I'm going to put 1 term beside each row. So since that first parentheses was m plus 3, I'm going to put m next to the top row. I'm going to put the plus 3 next to the bottom row. Now, my 3 terms will go across each column. So my first column is m squared. My second column is minus 2m. And my third column is plus 1. Have y'all seen this before? Okay. It just keeps you organized. So here's what happens. I am going to multiply this times this. First row, first column. And the answer goes in the box where they intersect, right there. So what would m times m to the third be? M cubed. So m to the third power is what I get when I multiply row 1 times column 1. Now, I'm going to go to this box. That means I multiply m times negative 2m. What's that? Negative 2m squared. What's m times positive 1? Plus 1m. Good job. Okay, now let's go to the bottom row. What's 3 times m squared? So that's a positive 3m squared. What's plus 3 times negative 2m? Wait a minute, multiply. Multiply. Negative 6m. Good. I know that's the tricky part. You got to make sure you don't get confused on am I multiplying or am I adding? And what's a positive 3 times a positive 1? Plus 3. Now, here's the really cool thing. By doing it this way, if I have like terms, they show up on the diagonal. Now, my m to the third, I only have 1 of those. But do you see more than 1m squared? Right here. Do you see more than 1 m? Yeah. So when I say they show up on the diagonal, it kind of organizes for me and makes it easier to find what I'm looking for. So all I have to do now is pull it out of the box. And if I'm going to write it in descending order, I'm going to put that into the third first. Now let's add the positive 3m squared and the negative 2m squared. What's that going to give me? 1m squared. And let's add the negative 6m plus 1m. What would that be? Minus 5m or plus a negative 5m. And then what goes on the end? Ta-da! That to me is much, much easier than trying to keep up with getting all those terms all spread out and trying to find what would be my like terms. This way my like terms show up on the diagonal as long as I started in descending order. Okay? So let's see if you guys can do this one. Now I want you to tell me, I've already got the box there, what would go outside the rows? What would you put here? You put an X here, and what would you put down here? Minus 5, okay? What would you put up here? X squared, then? Negative 3x goes here, then? Okay, now let's see if you can fill in the boxes and combine line terms. I'm going to walk around and check on you. Most of you got this. The trick is just making sure you don't leave anything behind when you start pulling them out of the boxes. So the x times x squared was x to the third, right? What went in this box? negative 3x squared. And then x times 1 was just 1x, right? Then when we went to the bottom row, this box was negative 5x squared. And this box was good. A negative times a negative gives you a positive 15x. And this box was negative 5. Okay, did you get your boxes right? So we've got the pattern down on how to fill that in. If we looked for like terms, you should have found these two were like terms, and these two were like terms. So when you pulled it out, it was x cubed. What came next? A negative 3 plus a negative 5 gives you a negative 8x squared. 15 of these x's plus one more of these x's is plus 16x. And then don't forget the minus 5 on the end. That's right. Can't forget the little fella on the end. So, I know. So you don't have to use the box, but I like the box just because it keeps me organized and I'm not as likely to leave terms behind. I will mention, I know I told you guys this was probably going to be the last thing we did. All we've really got left to talk about is a special case of multiplying polynomials when it's a binomial times a binomial. You guys remember something called FOIL? What does FOIL stand for?
First, outer, inner, last.
That is correct. First, outer, inner, last. Now, could you still make a box that's a 2 by 2? Absolutely. But if you know how to use FOIL and you want to use FOIL when it's a binomial times a binomial, then feel free to do that. And so we're going to stop here.